Okay, so this is problem 7.5 out of Griffiths. It says a battery of EMF and internal resistance R is hooked up to a variable loaded resistor R. If you want to deliver the maximum possible power to the load, what resistance R should you choose? So I just drew this circuit diagram. We have epsilon and we have this internal resistance here as well. And then we have our loaded resistor in our circuit. Okay, so using Ohm's law, our current is just equal to the voltage over R. And our voltage is essentially our EMF. So even though EMF stands for electromotive force, it's not actually a force. It's really more of a voltage. And then our resistors, I should say our total. Well, that's just going to be capital R plus little r in series. So the loaded resistance plus whatever that internal resistance is. They're not parallel to each other whatsoever. They're going to be in series. And then we need to remember our power equation, which is that P equals I squared R. Or, in this case, epsilon. I don't know if that we would call it epsilon, but whatever. Plus big R over little r squared times R. So that's our power equation. Whenever you see the word maximum in physics or math or wherever, you should think of derivatives like we did in Calc 1. So the derivative with respect to R over power is equal to epsilon. That's just a constant, d by dt, big R over big R plus little r squared. We want to find where that's equal to 0. Now in the question it mentions you can't change the EMF in little r, of course. So we can, the only thing that's variable here, it mentions it up here, a variable load resistance R. That's our, what we're taking our differential with respect of. And we set it equal to 0 to find a maximum, so this can just be moved over. That should have been squared, but again, it doesn't matter because it's just being moved over. So we have, I'm just going to rewrite this, d by dr. You have this big R. We could have done a quotient rule here, but I usually just rewrite my quotients as just product rules because those are easier for me. Is equal to 0 still. Derivative of the first is just 1 times the second. So r plus little r to the minus second plus r, the first, times the derivative of the second. So that's going to be times -2. So this is a chain rule to the -3. And then times 1, so we don't have to worry about that. This is all equal to 0. Okay. Or we could go ahead and multiply over so that this cancels with this. 2 of those. So we're basically multiplying by r plus big R plus little r squared. So we're going to get 1 plus r over, I guess, minus 2r, like that. Well, in that case, 1 is equal to this, or big R plus little r is equal to 2r, or simply little r is equal to big R. Okay? So we find that our maximum is when our loaded resistance is actually equal to our internal resistance. So that's how you solve problem 7.5. I hope it helps. If it did, please subscribe to the channel and maybe even like the video if this has helped you in any way.